Hello everyone. So today in this video we are going to solve a question of LeetCode, that is split array largest sum. This is 410th question on LeetCode and this comes under hard category. Alright, so let's start with the problem statement. Given an array nums which consists of non-negative integers and an integer m, you can split the array into m non-empty continuous subarrays. Write an algorithm to minimize the largest sum among these m subarrays. So basically in this question we have given an array, that is nums, and we have given integer m that will be equal to 2. So basically what we need to do is we need to split this given array into m parts. M is basically the count of subarrays. All right, so let's see how can we do this. Let's, in the first example, we can split this array by this part. So the first part will be 7, 2 and 5, and second part is 10 and 8. So when we split in this way, the maximum of sum of the subarrays is minimum. All right, so let's see. Let's take some cases. So like in this condition, we have 7 plus 2 plus 5. So 7 plus 2 is 9, plus 5 is 14, and 10 plus 8 is 18. So maximum out of them is 18. And let's say for this condition, we have 18. Alright, now let's see for other conditions. Let's say we split array only by one element. So in this case, we have 7, and another one we have 8 plus 2, 10, 20, 25. Alright, then second one is 25. So maximum out of them is 25. So we will be writing 25 here. Alright, now let's split the array in some other way. So some other array would be, let's split it by this one. So for this split, we have 7 plus 2 equal to 9, and 8 plus 5 plus 10 would be equal to 23. So this would be 23. Alright, so this would be 23. So the maximum out of them is 23. Now let's split this array by this one. So we have already split it by this part. Let's split it by taking only last element. So if we take only last element, then we will be having some like the sum of this part is 7 plus 2 9, 9 plus 5 is 14, 14 plus 10 is 24, and last one is 8. So maximum out of them is 24. So the minimum of maximum sums is 18. So we will be returning 18 in this case. Alright, now let's see how can we approach this question. So to approach this question, there are multiple algorithms. First one, we can use dynamic programming, but dynamic programming will take a lot of time and even it will take some space. So the optimized approach to solve this question is binary search. So let's see how can we approach through binary search. So basically binary search is an algorithm in which we search an element in time complexity around big O of log of n, and the condition is the array must be sorted. So in this case, the array is not sorted. So what we will be doing, this is some other kind of problem in the binary search. So we will be applying binary search on answer. So let's see how can we apply this on answer. So let's take two variables. Like for binary search, classic binary search, we take two variables. First one is L and second one is R. Let's see how can we initialize this variable. So L will be initialized with the maximum value of this nums array. So maximum value in this nums array is 10, and the R value is initialized with the sum of given array. So the sum of given array is 7 plus 2 9, 9 plus 5 is 14, 14 plus 10 is 24, and 24 plus 8 is 32. Alright, so now let's calculate m according to it. So m is basically the average of L and R. So the average of L and R is 42 divided by 2 is 21. So now m is equal to 21. Let's take one more variable to store our answer. Alright, so let's take one more variable which will be storing our answer. Let me write here answer. it will be initialized initially with 0. Now let's see guys, so what we can do here is we will be iterating through this array and we will be counting number of subarrays with the sum m, like with the sum m should be less than or equal to, like the sum should be less than equal to m. Alright, so let's see how can we do this. Let's iterate from the starting. So for this m we will be having one subarray will be equal to 7 plus 2 9, 9 plus 5 14, 14 plus 10 is 14 plus 10 is 24. So this is exceeding, so let's take this one and second array would be this one. So for this we are getting two subarrays and 2 is equal to m. So for the condition where the number of subarrays should be less than or equal to m, what we will do, we will update r with m minus 1. Let's update with m minus 1. So now r will be equal to 20. Alright, now let's update answer with m. So answer will become 21. Alright, now let's calculate m according to it. So m would be 10 plus 20 divided by 2, so m would be 15. So let me write 15 here. Now let's see how many subarrays are there. So we have one subarray with 7 plus 2 plus 5, so 7 plus 2 is 9 plus 5 14, 14 plus 10 is 24. We cannot take 10, so this one is the one subarray, this is one subarray, second one is 10 and third one is 8. So there are three subarrays with this. So when there are subarrays greater than m, we will be updating l. So let's update l. L will become equal to m plus 1. M plus 1 would be 16. Let's calculate m according to l and r. So our l is 16, r is 20. Let's calculate m. M is 16 plus 20 divided by 2 is 18. So m will become 18. Alright, so now let's check the number of subarrays. So number of subarrays for 18 is, we have one subarray with this one and second one is this one. So we are getting two subarrays here. Alright, so we are having two subarrays that will be equal to m. So let's update r to m minus 1. So r will become 17. Let's update our answer here. Answer will become 18. So we should keep eye on answer, because whenever we update r, then only we can update our answer. If we update l, then we don't have to update our answer very well. Alright, so you should keep this in mind while coding. So let's calculate m according to it. So m in this case is 16 plus 17 divided by 2 is 16.5. 16.5 in integer is 16. So m would be 16. Now let's calculate number of subarrays with 16. So 7 plus 2 is 9 plus 5. 9 plus 5 is 14. 14, then this will be the subarray. Second one is 10 and third one is 18. So number of subarrays here is 3. 3 is greater than m, so L will be updated. So L will be equal to m plus 1, that will be 17. Now let's update m. M would be average of this one, both are 17, so average will also be 17. Now let's calculate for 17. For 17 also we will be having 3 subarrays. So let's update L to 18. Alright, so now we have L is greater than R. So in this case what we will do, we will be returning answer. Alright, so we will return 18 from here. I hope the approach is clear to you. Let's quickly code it up. Alright, so let's take two variables, int l is equal to 0 and r is equal to 0 initially, and also take a variable answer that will be initialized with 0. Now let's calculate L for this. So L for this is, let's take for auto x, let me take auto x and nums. Alright, so L will be equal to maximum out of, like the maximum of whole array. So this will be maximum ln x, and R will be the sum of all the elements. Alright, so this function, this for loop will calculate L and R. Now let's run a while loop until L is less than equal to R. Now let's check. Let's take first count. This will be counting the number of subarrays. So let's take a helper function here. We will be declaring helper function later in this video. So int count is equal to helper. Let's pass nums from here and let's pass mid from here. Let's calculate mid here. So int mid will be equal to L plus R divided by 2. Alright, so now let's check. If count is less than equal to mid, then let's update R to mid minus 1 and update our answer to mid. Else in other conditions, let's update L to mid plus 1. At the end, just return answer from me. I hope this is clear to you. Let's initialize a function for our helper. So this will return int from here. Let's take vector of nums and let's take a variable int mid. Alright, this should be m. Yeah. Alright, so let's take two integer variables. So first one is int count. This will be counting the number of subarrays. So let's initialize it 1 because at least one subarray would be there in an array. And let's take another variable which will be storing the temporary sum that will be initialized with 0. Alright, now let's run a for loop to iterate through our given array. So int I equal to 0, I should be less than nums dot size and I plus plus. Now let's check if temp sum plus nums of I is less than equal to mid. If this is less than equal to mid, then add temp sum plus equal to nums of I, else update the count and let's update temp sum with nums of I. This is basically calculating the number of subarrays which have a sum less than or equal to mid. Alright, so at the end we will be returning count from here. This is count, so let's this one. Yeah, so we will returning count from here. I hope this is fine. Let's just run it. Yeah, it's working fine. Let's just submit it. Alright, so let's calculate the time and space complexity. So the time complexity of this solution is big O of n log of n. This is because this for function will run n times. So this will take around n, and the time complexity of this while loop is log of n. So altogether is n log of n, and space complexity of this solution is big O of 1 because we are using constant spaces in this solution. So yeah, I hope the approach is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video, subscribe to our channel. Thank you.